Today you have a warm-up that comes from your workbook on page 451. You are going to complete it in there. Your job is to measure the height in centimeters and inches of each of the images, rounding to the nearest centimeter or the nearest half of an inch. So you'll record those measurements here on page 451. The video is based on a drawing called The Vitruvian Man by Leonardo da Vinci, a famous Italian artist, scientist, and inventor from the 15th century. The drawing is named for Vitruvius, who studied relationships between measurements in the human body in the 1st century BCE. Here we have a list of different relationships found within the body. The length of the outspread arms is equal to a man's height. The distance from the hairline to the bottom of the chin is 1/10 of the man's height. The distance from the bottom of the chin to the top of the head is 1/8 of a man's height. The distance from the elbow to the tip of the hand is 1/4 of the man's height. The length of the hand is 1/10 of a man's height. The length of the foot is 1/7 of the man's height. And the distance from the bottom of the foot to just below the knee is 1/4 of the man's height. Record a claim you want to investigate. Let's investigate the claim that the distance from the hairline to the chin is 1/10 of the height. Now we're going to need to examine multiple people in our class to help us determine if this is true. It may not come out exactly as 1/10 or 10 times, but if it comes out close, that's going to help us determine whether this statement or claim is true. Again, this is an analysis, and we're investigating whether this ratio works. It probably won't be exact for everybody, but it should be close for most people in order for us to say whether this claim is true or false. So we're going to follow these steps to investigate. We're going to develop questions that can be answered with data, create and use a plan to collect data, analyze the data, and interpret the results and draw conclusions to answer the questions. In problem 2, it says plan how you will investigate your chosen claim by completing parts A through C and present your response to your teacher for approval. First, what is your statistical question? The question we are going to examine is the ratio of the face to height length typically 1 to 10 for students in our class? Part B says what data will you collect and how will you collect it? I'm going to collect data on the height, and the length of their face from their hairline to their chin. And I'm going to measure both of those in inches. And we'll round to the nearest half of an inch. How will you analyze the data? Describe the data display you could use and the pattern of association you could look for. I could organize my data in a scatter plot. And if the slope is close to 10, that would indicate that this is a true relationship between the size of the face and the height. For the record your data piece, if you have multiple people in your home, you can measure them in inches. Remember, rounding to the nearest half of an inch. Otherwise, you can use the data collected by our class to help you build a scatter plot. I've set up a table with face length and height. Remember, we're measuring both of these in inches and rounding to the nearest half inch. So here's the rest of that data for us. We'll move into building a scatter plot in the next slide. So on our grid, on the x-axis, we have the face length in inches, counting up by halves. On the y-axis, we will have the height. We'll indicate that we're skipping some data on our graph, just so that way we can zoom in on the heights. And then we will graph those points. So I have 764, 7.5, 70, 7.5, 74, 765, 662, 7.5, 68.5, 8, 72, 6, 65, 6.5, 67, and 661. Then we'll draw our line of best fit, or our trend line. I want to make sure that it's as close to the points as possible. Now let's examine our trend line to see if we can figure out what the slope would be to help us answer our statistical question. I see there's a point here, and it appears to be a point up here. This would be the point 5.5, 60. And this would be the point 7.5, 71. So if we find the difference in our y values, that's a difference of 11. And the difference between our x values, 5.5 to 7.5, is a difference of 2. So our slope is approximately 5.5. We may need to adjust our trend line a little bit because we have 1, 2, 3, 4, 5, 6, 7 points below and only 3 above. In doing so, we have the point 7.5, 70, and the point 5.5, 59, which is a difference of, right, which still comes out to 11 and 2. So our slope is still going to be 5.5. So my question was, is it typically a value of a ratio of 10? And it did not come out that way. Perhaps a different solution or a different display would be helpful. So for example, we used the scatter plot, but if we look specifically at each piece in the table, if I did 64 divided by 7, that's about 9.14. If I did 70 divided by 7.5, that's a ratio of about 9.33. 74 divided by 7.5 is 9.87 when it rounds. 65 divided by 7 is 9.29 rounded. 62 divided by 6 is 10.33 when we round. 68.5 divided by 7.5 comes out to 9.13. 72 divided by 8 is 9. 65 divided by 6 is 10.83. 67 divided by 6.5 is 10.31. And 61 divided by 6 is 10.17 rounded. So perhaps looking at the slope doesn't give me an accurate picture of that ratio for this specific scenario. So it may have something to do with the outliers. Or possibly an initial value. They may be impacting the slope that we get. But you can see based on the division of the heights and the face length that it does come out to around 10. So perhaps I needed to look at a different display of the data. It says describe one difficulty you had during your statistical investigation and one possible solution. The difficulty I had was that the scatter plot did not line up with my expectation. A possible solution is that I might need to collect more data to minimize the impact of the outliers. I may also need to examine an alternative data display to determine if the ratio is typically 10. That's the end of lesson 16 for us on using the investigative process. In class, your peers may have chosen to use a different question to analyze, and so your data would look different based on which question you examined.